All right. Good day. I'm by name Waseni Agaba Amos from the Department of Human Anatomy, Neuroscience Unit, Faculty of Basic Medical Sciences, Ahmadu Bello University, Nigeria. I'll be discussing on how Solanum esculentum could help salvage motor dysfunction and neuronal damage. First, doing this, we had to make use of a chemical, a herbicide called Paraquat. Paraquat is a superoxide generator. These oxidants that this herbicide could and can generate impair motor activities. It also impair open field locomotion and hind limb function. It also causes neurotoxicity, which in turn destroy neuronal cells. Paraquat, despite the ban from Western world, Paraquat is a herbicide largely used in most developing countries like in Africa. Paraquat is very toxic, be it any route of ingestion, either oral or by touch. It is very, very toxic. It is labeled a danger poison signal according to the Pesticide Information Profile in 1993. Meanwhile, tomato Solanum esculentum contains valuable phytochemicals and antioxidants, which could help salvage all the motor dysfunction paraquat can cause. This study is to determine the ameliorative effect of ethanolic extract of tomato on cerebellum and spinal cord changes induced by paraquat dichloride. The materials used for this study includes a paraquat dichloride, which is manufactured by Sinicon Nimbo Limited. Treatments were via oral, and they lasted for 12 consecutive days. Neurobehavioral studies were carried out to ascertain the effect on motor coordination. Animal ethical clearance was issued by Ahmadu Bello. The neurobehavioral studies taken, which was used in this study, include force power string test and footprint analysis. This is the image of the footprint string test and the apparatus used in taking the footprint analysis. Animals were humanly sacrificed after taking the neurobehavioral test, and the animals were initially grouped into 5 groups. Group A served as the control groups and were given 30% of the paraquat dichloride, which is the LD50, while Group B received the paraquat dichloride, the LD50, 30% of the LD50, while Group C received 30% of the paraquat dichloride and 1,500 milligram per kg of tomato extract. Tissues were sectioned and viewed under light microscopes. Here are our results. From the results seen here, the footprint analysis and the 4 power string test showed a decrease in the distance of the forelimb strides and the base, with increased duration of administration. Also, there was a significant increase in the grip strength, which was observed in the control group, while there was a decrease when it is being compared with Group B, which received the paraquat dichloride. This showed that paraquat dichloride could induce spinal cord damage and also could decrease the forelimb strength, which means it could damage neurons in the cerebellum, which controls the motor activities. This is the table showing the results gotten from the footprint analysis test. There was a significant decrease in the forelimb stride and the forelimb base of the animals, Wistar rats. These were the histological sections gotten from the Wistar rats after being sacrificed. Plate 1 shows the section of a Wistar rat cerebellum of the control group. The control group showed viable cells, while the plate 2 shows the cross-section of the cervical spinal segment of the spinal cord of group 1, which served as the control group. Plate 3 shows the section of the cerebellum of adult Wistar rats, which were treated with 30 milligram per kg of paraquat dichloride. This session showed a very, very poor viable cells, and it shows loss of Purkinje cells, while that of the cervical segment of the spinal cord shows degenerating cells, degenerating nucleus, and congested nuclei. For the group which we are giving 30 milligram per kg of paraquat alongside 30 milligram per kg of tomato extract show viable cells, and it also shows a level of degenerating cells. Plate 5 shows the cervical segment of the group which also received 30% of paraquat dichloride and tomato extract, 1,500 milligram of tomato extract. This is the histomorphometric study carried out on the cerebellum and cervical segments of the Wistar rat spinal cord. The cerebellum and the cervical segment of the spinal cord of the Wistar rat shows a good number of cells and with large volumes in the control groups, while there was a decrease in this cell volume in group treated with paraquat dichloride. But there is a significant level of increase in these viable cells in the group treated with just the tomato extract. This study shows that loss of these Purkinje cells could result from degenerating cells and paraquat toxicity. This is in accordance with study carried out by Jaisen and Seneverant at 2016. Paraquat toxicity can lead to loss of motor coordination among these Wistar rats due to the toxicity and superoxide it generates. This is in accordance with the work carried out by Songin et al. In 2010. The group treated with paraquat dichloride and tomato extract showed some viable Purkinje cells in the cerebellum, with intact nuclei in few areas. We saw some degenerating cells. This is due to the improvement and ameliorative effect of this tomato extract. That is why we could see some viable cells from groups treated with tomato extract. This is also in accordance with a work carried out by Tok et al. In 2013. Severe histopathological distortion in the cervical segments of this spinal cord group treated with, and spinal cord section treated in groups treated with 30 milligram per kg of paraquat dichloride manifested as neurodegenerative changes such as degenerating cells, disintegrating nuclei, congested nuclei, and loss of neuronal fibers when compared with the spinal cord section of those in the control group. Notwithstanding, there was a reduced number of Nisu bodies found, and apoptosis. This may be due to apoptosis or necrotic neurons. A significant decrease in the cerebellar cell volume among group treated with 30 milligram per kg of paraquat, and insignificant decrease in cell volume among those treated with paraquat dichloride and tomato extract was observed. A significant decrease in cell number in the group treated with paraquat alone was also observed, while there was an insignificant increase in the number of cells among those treated with paraquat dichloride. The decrease in cell number could be as a result of induced apoptosis by the paraquat dichloride, though the cell could be present with intact nucleus. Decrease in volume may be deficit impairment in the normal cellular activity, such as energy metabolism, enzymes, and substrate concentration, protein synthesis, cell division, which in turn could affect the normal function of tissue or an organ. The increase in the cell volume and cell number in some groups could be attributed to the ameliorative effect of tomato as a result of its antioxidative property. Also reported by Gansels, Valinas et al. In 2013, who reported that tomato contained carotenoid and its function related to their antioxidant power. So, in conclusion, paraquat dichloride induces neurotoxicity and damage to the cerebellum and cervical spinal segments. The spinal cord of adult Wistar rats manifested as neurodegenerative changes such as degenerating cells, disintegrating nuclei, congested nuclei, loss of neuronal fibers, and perineural vacuolations. Tomato has a neuroprotective potential against paraquat-induced cerebellar and spinal cord lesion in adult Wistar rats by maintaining the cytoarchitecture of the cervical spinal segment. This could be consequent on the presence of antioxidant properties and phytochemical present in tomato. Some of the recommendation I'll give is if there'll be a way where this dangerous and poisonous herbicide could be banned in developing countries just the way they are in the Western world, because this paraquat dichloride could induce neurotoxicity and impair motor function. Notwithstanding, it is recommended that high consumption of tomato could help salvage and this motor dysfunction and neuronal damage. Here are some of my references. Thank you.
Thanks for your presentation, Waseni. So, like, you can hear me, it's okay?
Yes, I can hear you.
Yeah, perfect. So while we are waiting for some question on the chat, like I will ask you one. So Natasha was actually wondering, how did you choose the dose of your treatment? Is it based on agriculture? Like, do we know what dose is can be can just be mortal? Like, uh,
The dose was actually chosen on the basis of the LD50 as recorded by Kimbrough et al. In 1957. So we gave 30% of the LD50 to avoid much damage.
okay. So like we'll wait. We'll wait a little bit to see the question of the chat. Like there is a little delay with the stream, so like it's possible that question will arrive delay too. Okay, so Natasha is just follow up the first question and just ask like if the dose are actually corresponding to the dose used in agriculture.
Sorry, come again?
So Natasha is follow up last question and ask if the dose are actually corresponding to the dose used in agriculture.
Okay, no, it doesn't correspond with the dose used in agriculture because this is an herbicide. They are used to kill weeds, but there is LD50 determined by Kimbrough et al., which states that this LD50 is actually lethal, and the dose used in agriculture is even higher than the LD50.
Okay, thank you. We have another question from Okwashiki Ombugadu. We say, nice talk. Why did you decide to use only ethanolic extract? What is the lethal concentration of paraquat that will cause 50% and 90% damage of the spinal cord cells?
Okay, we actually used only ethanolic extract of the tomato due to some financial constraint, and um, in this part of the world, it's actually science is not actually funded as it were in other parts of the world. So the LD50 of the paraquat dichloride is about 100 milligram per kg.
Okay, thank you. So like we can wait 1 more minute to see if there are more questions. And like anyway, if there's no more question now, like I'm sure that if people have more questions, they will go to your Discord channel.
Okay.
So yeah, I think we'll run out of time